So what I'd like to talk about today is basically how you can run your own Prometheus and why you actually want to do that, and then what guides you through the process of actually spinning it up from scratch, which in all honesty shouldn't take you more time than about 30 minutes if you have basic knowledge of the matter. So first, a bit of context. We currently have some platform metric stack in the cloud based on Prometheus, which basically is constituted of several parts, but the most important is in the middle, and it's our platform Prometheus. If you go to prometheus.bottle.io, that's basically where you end up. And that Prometheus just sends alerts that you define to an alerting stack based on resources you create in your application projects in R2D2. So you create a simple service monitor, which scrapes your target, you define alerting rules, all this gets picked up by Prometheus, and everybody's happy. So this current platform has some properties that I'd like to talk about. Basically, that we scrape all the targets every 30 seconds. We keep all the metrics for about 31 days. And we allow you to query about 50 million samples so that you don't just explode the amount of memory the platform Prometheus is using. If we take a look at the current platform, we store about 6 million individual series, and that's about 21,000 metrics. If you take a look at the amount of jobs and targets that this results to, it's 600 jobs. So on average, 5 targets per job. So if you look to Prometheus in, for instance, the up metrics, you can see that for every single job, we have about 5 ups. But this also comes at a fairly high cost currently. We have about almost 2 terabytes now of data stored for only 31 days of retention. We have about 130 gigabyte of RAM and 11 CPUs. So if you think about it, 11 CPUs for 6 million series is not so bad in the end, especially if you consider the fact that we're scraping 3,000 targets. So that's 3,000 HTTP calls every second. So it's pretty efficient in the end. But still, this has some limitations, namely that if you want to gather metrics for longer than, say, 31 days, currently that's just not feasible. There is no way for you to get past that barrier because this is something we've set on the platform, and it's a hard limit. If you want metrics with a resolution that's lower than 30 seconds, it's also not feasible currently, as in we enforce that the basic resolution is 30 seconds for everything. And it's a good middle ground for us in terms of scalability and for you in terms of precision. But if you want something that's lower than that, currently with the platform solution, that's just not feasible. And then there's a problem of scale, which is the one we're facing most. If you use Axel with micrometer and you start looking at histograms, you know that you have out of the box like 100 buckets. And that's very nice because it gives you a really good precision on histograms. But the problem is that the moment you start trying to query that, it becomes really expensive, really slow. And the reason for that is cardinality. Namely, every time you create a metric with a lot of labels, for every single key value pair of labels, you basically create a whole new timeline, a whole new series. And if you try to aggregate over all of those, it becomes really expensive. So that's the main limitation. And we have ways to fix this currently, which is just run your own Prometheus. And the objective for us in the long run with this is, say, you want to have metrics, you click a button, you have a template opening up, and you can switch values just based on what you would like where is it accessible, what retention do I want to have, what the scrape frequency do I want to have, which resolution, and then based on that, just spin up an entire metric stack for you so that you don't have to worry about it. It will just come up with basic alerting for it, basic dashboards automatically that you could get, and of course the metric stack. So you could send metrics through the push gateway or start scraping stuff immediately. So for today, my objective is mostly how to get from 0 to 100 within about 30 minutes, including the R2D2 runtime, provided the demo gods are with us. And what we'd want to provide in the end is basically an alerting platform and monitoring platform based on Prometheus. So same as you're currently doing with Alert Manager and ISON call in the cloud. basic building blocks, so the Prometheus instances, standard alerts that we want to provide with it so that you don't have to worry about this, basic dashboards eventually. We also want to provide very good documentation about how this whole works altogether, how you can start from scratch, how you can troubleshoot when things go wrong with runbooks, and also frequently asked questions like, okay, I can't find my metrics, or how do I add, for instance, the push gateway, stuff like that. And finally, what's really important is that, well, if everybody spins their own Prometheus, it's nice, but we also want to be able to query them and graph them and add dashboards. And it becomes really inconvenient if every time someone adds a Prometheus, we have to add yet another data source in Grafana. And then you have, again, to switch data source every time you create a new dashboard, and it becomes really inconvenient. So we want to provide a single query endpoint in Grafana per environment currently, using something called Thanos. And Thanos is nothing more than a single aggregated view of lots of Prometheuses behind one data source, one API in the end. So what it will look like in the end, if you take a look, it's very simple. Instead of having a platform Prometheus that does everything, in your application project, in your application namespace in JK, you spin up your own Prometheus, and this Prometheus is then going to do the job of scraping your targets by service monitors that you define. It's also going to evaluate your alerting rules and then send the resulting alerts to the alerting stack, Alert Manager, and Iris on call. And then as a user, you will just have to go through Grafana, as you always do, create your dashboards, but select only the fact that you want your own Prometheus as a label on the query. And that's about it. There is really nothing more to it than basically this. It should be just that simple. What I'm currently going to show is going to be imperfect at the time, because simply, well, we're still improving, we're still learning on how to make this as simple as possible. But we're really trying to improve on the existing with all the feedback that we can get. So if you have any feedback to provide, if you think things are unclear or a bit too complicated, that it could be simpler, don't hesitate also to notify us, and we'll try to take it into account and improve as soon as possible. So for instance, currently I know that you can spin up, for instance, Prometheus with, say, 2 replica, and you have to specify in which zones, as in Google Compute Engine zones, it should live. And this is not exactly convenient, so we want to make that easier in the future. And we already know it's a shortcoming, but we'll try to improve on it. I see a question about, is Thanos currently used for the mixed data source in Grafana? Not exactly mixed. If you look in Grafana, you have basically 3 main data sources. You have GCP production, GCP staging, and dev. Behind all those 3, Thanos is actually living. So whenever you're using GCP production, you're actually going through Thanos to talk to a whole lot of Prometheuses, including the platform, but also the Istio metrics, but also the people who already spin up their own Prometheus, including the insights team, because, well, if we're trying to get you to do something, we're going to try to do it ourselves first. That way we can make sure that everything is going all right. And that's about it for this introduction. There's nothing really more to it than this. It should be just that simple. So you can always ask questions. Otherwise, we can take a short break before the quick demo. All right, I think we can start again. The first part, I just wanted to give some context about why we would actually want to do this, why the platform is not always suitable, especially if you really have some very different requirements than what we're currently doing, different SLAs. And now I actually want to show you how you can get there yourself. So this is going to be a demo about step-by-step how we can get from having nothing in place to a fully complete Prometheus instance running and scraping some basic targets. So on the right here, I have basically a simple application project called Prometheus Demo. It's running in staging, and it has the nice with JK flag, which allows me to do stuff in, well, JK, so Kubernetes engine. The only thing I'm adding to this for now is a simple Prometheus instance called demo. So I've cheated a bit for now, and I've run already this spec, and it's been successful. So awesome. Proof is here about 15 minutes ago. And it's worked beautifully, because if I start looking at pods that are running in my Prometheus demo namespace in the staging cluster, and this is the second one, by the way, there's a Prometheus demo pod which has been running for about 50 minutes. So nice, I have a Prometheus. First thing I want to do is then probably access it. So what I'm going to do is just port forward to it, because, well, that's the only way currently that we have to reach it, but we're going to improve on that later on to make it simpler. So this is just going to establish a connection between my laptop on port 9090 to the actual Prometheus instance running in JKE, so I can access the web UI. And now if I go to my browser, type localhost 9090, then I can have my Prometheus instance. So nice, we have a Prometheus instance running. It has some properties already. We can see its uptime, so it's been up for about an hour, 50 minutes. And currently it's completely sadly empty. Also, it's running on localhost, which means it's not exactly convenient to reach. So let's try to improve on that. The first thing you likely want to do is, add a target, because otherwise, what's the point if we can't monitor anything? So I'm going to add that to my spec, and well, again, let's hope that this actually works. Since this is step-by-step, feel free to interrupt, ask any questions, because, well, the executions are going to be quite long, but I really want to show you that there is no trickery, that it just completely works out of the box, provided you follow along. There's documentation, by the way, available to follow this. So if you go to docs.bol.io, sign in, of course, and look for metrics monitoring and logging, there's a Prometheus in the cloud page with deploying your own Prometheus. If you click on that, you have exactly the same steps that I'm now taking to spin my own Prometheus, with exactly the same details and explanations about what some of the parameters that you might want do. So for instance, how to select service monitors, how to expose or make a highly available setup. So I'm going to go through all of that today as well. But if you want to get back to this later on, don't hesitate to look at the documentation, ask questions. I'll put also the sources of my demo on GitLab as well. Let's see. So this is still running. And what we can see is that indeed it added the service monitor that I just created. And this service monitor, by the way, is not going to do anything crazy. It's called Prometheus Self because it's simply going to select the Prometheus demo instance that we just created and scrape it. So just normal Prometheus stuff. One of the things we can see is it's also adding a bunch of parameters that we didn't specify currently, like for instance, the sample limits. Those are same defaults that we add on top of the resources. So that by default, you don't just overload Prometheus with, say, 1 million metrics if you're exposing that amount. If you need more than this, you'll need to change those parameters, but then I'd refer you to the actual documentations that we currently have for this. And this is done. So if we go back and look at our Prometheus, it has a last configuration reload time, which allows us to see when was the last time it actually reloaded its configuration. And this just allows us to see if the change we added, namely a service monitor, got picked up. And you can see it just changed from 8 something to 9:30 UTC, so about 11:30 now, which means if everything goes all right, that should have a target that's up. Awesome. So I can actually start querying stuff. Let's say, for instance, my Prometheus instance is actually up, and I can see probably also the amount of requests that was done against it, which is also quite a lot already. So for instance, you can see that the health probe for Prometheus is working because the handler for the health probe, which is /healthy or /dev/healthy, already had 640 requests made against it. So that's cool. That means that everything works. That's nice, but it's not exactly convenient to have to port forward to it. So let's scrape that. And go towards the make it accessible. So all I'm going to do is add an endpoint parameter to say where I want this to be accessible. Namely, in my case, I want it to be at prometheus-spaces-summit.station.bol.io. And this is going to make it accessible at this very record. So let's try that. Going back to RTD2 and run the spec. Under the hood, what this is going to do is create for you a service for Prometheus, attach it a DNS record so you can access it and give it a local IP in our local network range. There's nothing more to it. Again, it's all very simple. It's just that I want to go only very small step at a time so that this doesn't get really complicated. Then we can also then get rid of this one, since we'll be able to access it here. Let's just follow the execution. So if we look for now at what's happening, we have a service of type cluster IP, which means that we can't currently access this Prometheus instance. With this endpoint, we're going to change that to a load balancer and make it accessible through our ingress, which you can see here. So we added this ingress automatically for you just by adding this parameter. And this is where we get all the benefits of working with RTD2 currently. We try to wrap existing piece of software. All we're doing is currently supported by open source software taken from, for instance, CoreOS, which is part of Red Hat now, and just wrap it in RTD2, make things simpler, provide sane default so that it's as simple as possible. And under the hood, it's actually doing a lot. So you can see, for instance, that it's adding an ingress, it's changing the external URL to make it accessible at the right path, and so on. So that works. Let's make sure that everything actually worked properly. So if I look at the ingress, I have one. It's named the same as the record I want to add, and it just got live. So let's see if I can actually reach it, provided DNS is with me. And nope. So I was a bit afraid of that. It could take a minute. What I'm going to do is continue on and assume this is working. If it turns out it just comes live later on, awesome. Otherwise, we can just continue with port forward. So it's nice that we can access it, provided it works. But what would be nice is also we always have JKE upgrades running once a month per 1 week, every week, one environment. And we need to be resilient to that. If our monitoring falls down because there's a JKE upgrade, well, that sucks because we don't want to lose our monitoring. So what we want to do is add some resiliency, some highly available setup for our Prometheus instance. So the only thing we're going to do is say, instead of having one replica of the poor pod that we had before, we're going to have two instead. And just to make sure that we're resilient also to zone outages, like a complete Google Cloud zone going down, we're going to spread those two replicas across two zones. So what I mentioned before is that we have some things that are not completely optimal. This is one of them. Currently, you have to specify those zones manually. Eventually, we could also say, we do this for you. We already know this is not exactly convenient because you need to know in advance what those zones are. I think they are documented. We also mentioned in our documentation the lists that you can use. But in most cases, this is going to be West 4, B, and C, because that's where our clusters are actually running. So let's just run this. And apparently my ingress is still not working, sadly. So I'm just going to go with port forward again. One of the things we also get from doing this is currently I'm running on this demo the version 2.15.1. If you do it this way, you can see that in the spec, I never specify actually which version I'm using. What we want to do is, unless you have a specific reason to pin the version, we're going to silently upgrade stuff for you, which I think is acceptable because that means you get all the goodies at the right time. The only thing is that if you don't have a highly available setup, when you're going to run R2D2 and that version is going to change, it's going to take down your Prometheus pod. And if you only have one, well, that one goes down, you don't have monitoring. So you definitely want always to probably have two, unless you really don't care so much about resiliency, please do so. It's going to save your life more than once. And so we'll provide the default for now being 2.15.1 and increase it over time so that you don't have to worry about upgrades, for instance, or security updates, stuff like that. Since we actually use this for the platform and our own Prometheus for the Insights team, you have a guarantee that basically we test this first on ourselves on the Insights one, and then on the platform, which is a massive scale, more massive scale than what you'd have, meaning that we see probably all the problems that you can potentially have with the version upgrade. Let's see if my execution finished. One of the things we also add, and I think it's important to note, especially if you are not aware of how to make application resilient in Kubernetes, is what about disruption budget is. If you've watched Kevin talk about Kubernetes, you probably heard about this. It's just a way to say that whenever there's going to be disruption, for instance, maintenance or JKE upgrade, we make sure that at least one of the instances is available. And that's how we become resilient to those events. And we can see indeed that we're changing the amount of replicas from 1 to 2. So this is finished. Let's see if we actually achieved. Yes. So now we have our 2 replicas happily running alongside. So if the ingress was working, which I think it isn't still. Oh, it is. Awesome. So given the ingress is working now, DNS can be slow. Whenever you're going to hit this, you're actually going to round robin against those 2 pods. This is the same thing as a platform Prometheus. If you go to prometheus.bol.io, you're actually going to round robin against our 2 platform Prometheus pods. And this used to be a problem in Grafana, where if you refresh the dashboard, suddenly the graphs would jump around. And that's something that got solved by Thanos. I'll explain in a bit how. So I can get rid of my port forward now because it works. Awesome. And our next step would be then to have alerting working. So I'm not going to demo exactly how to add alerts or fire an alert right now. It's something that you probably have some experience with. If not, don't hesitate to come on the MML channel to ask. There is also pretty good documentation again on docs.bol.io if you go to the MML page and Prometheus in the cloud. All the way at the top, there is some explanation creating alerts that you can just follow through. So the only thing we want to add is just make sure that we specify which alert manager to reach. And this is another thing that is currently suboptimal that we can easily expand on later. Basically, just specifying this for you, making it the same default. Currently, you have to specify this parameter. So I'm just going to simply paste this, run it, and then answer a couple questions I saw. But this is not going to fundamentally change the functionality we currently have right now running because I have no alerts running. I could spin up a quick alert, but let's not tempt the demo gods too much. Running your own Prometheus will have a disaster recovery process in place. Yes, we are working on that. There was some efforts about disaster recovery recently. What we're also doing in our documentation or will be doing is explaining how to recover from a disaster, namely data loss, for instance, Prometheus going down. But keep in mind that it's also heavily tied to other things like the JKE platform on which we're running, the persistence disk in Google Compute Engine that you're using under the hood to store the data, and so on. But yes, that's something we definitely want to document because we can imagine this happening. It actually happened to us already a couple times. So it's all the better if we have that documented. I think we currently have our team's documentation with some mentions of that, but just not in the MML documentations. So this isn't going to fundamentally change anything in there. So there's probably very little that's interesting. So I'll probably just move on. Yeah, the execution went through, and the only thing that changes, there is a new field in our resource called alerting with a list of alert manager. So we're currently using the alert manager platform one that we deploy as insights for you. Later on, if need be, we could also think about spinning up your own alert manager, but this is really not required. This is a lot more complex than just Prometheus already, which is already by itself something that's, if you don't know anything about it, it has a learning curve. Not high, but still significant. So all nice, we have alerting working, and you have to take my word for it this time. Now, if I go to Grafana and I want to plot my metrics, currently I have nothing, and it's sad, but we're going to solve this. So I mentioned Thanos in the introduction. Thanos is nothing more than how to make Prometheus scale. It's an open source project coming from a company called Improbables and some people at Google, which allow you to put a simple query layer across multiple Prometheus instances, and also store those data for long-term, for instance, using downsampling, as in reducing the amount of samples you have over time, or storing the metrics in a bucket instead of a disk, which makes it a lot cheaper also, and compact them and so compress them. So again, a parameter that is very obscure right now because you need to specify the version and the base image to use, but it's something that we already have a ticket for that we know we can improve on. But all this is going to do is deploy yet another sidecar to our Prometheus pods. So you can see currently we have exactly 3 containers in a pod. So basically Prometheus itself, of course, but also a configuration reloader and some other things. We're going to add a 4th one, which is going to expose a new API that Thanos can then use to communicate with it. And that API is based on gRPC. Just some trivia about it. So let's do this. And let's hope we can actually get this to work also. So what it's going to do is, indeed, like I said, spin up a new sidecar. When it is done, your Prometheus instance will be accessible from Thanos. So I've cheated a bit in this case, because this actually requires some action from the Insights team to add your Prometheus to Thanos. We have a list of all the Prometheus instances that should be included in Thanos. And based on that list, Thanos is going to add it to the stuff that it can query and then on Prometheus. I see a question, what's the difference to keep in mind between defining Prometheus rules for alerts in RTD spec file and Grafana alerts? We prefer the Prometheus rules in RTD2 spec file because that allows you to define alerting as code. So your entire monitoring setup is then reproducible, meaning that we can easily, in case of a problem like data loss, you accidentally deleted your namespace, your monitoring can be put up really fast. Grafana has also alerting as code, as in you can dump your entire dashboard as JSON, but it's a lot less friendly to do it this way. It also has some quirks. Alerting was added after the fact in Grafana, meaning that it's kind of bolted on. So it works, but we prefer, the preferred path is definitely to use alerting rules. Question also, if I can give a few examples of how your own Prometheus setup will help you. Can you give some examples? Yes, I'm going to come to that in a second. So I've added Thanos. It just added the exact same fields I've added to my resource. It's changing one of my services to add the gRPC API and added an extra service for the sidecar. Awesome. So let's see if I can get something now in Grafana. And looks like it. So if I take a look at my Prometheus demo, or if I take a look at the namespace Prometheus demo in the cluster in which it's living, we can see I have a few targets running. That means that I can actually query what's happening in that Prometheus instance. So if I were to look, for instance, here at Prometheus HTTP request total, which is all the HTTP requests that's made against Prometheus itself, I can see, that currently we have about 83 for the health probe on one of the pods. So let's try to replicate that in Grafana, see if I can actually get somewhere with this. And there we go. So you can see this is loading, ramping up, which makes sense because it's in a health probe, so it's queried every now and then. So this works, awesome. Just making sure that I didn't get everything right. So one of the reasons you'd actually want to do this is, say you want to compute an SLA or an SLO over a quarter because you're doing SRE and you want to compute your error budget based on every quarter, or how much time you were down for a quarter, just to give some management people some nice KPIs. If you were to do this currently, you would be limited to basically 1 month with the platform Prometheus. So that's just way too low for this kind of calculations. If you were to spin your own Prometheus, you could here say, I want to have a retention of, for instance, 90 days or 365 days because, well, why not? I can. So that's the main advantages. Same if you want to say scraping period. I want a data point every 10 seconds because I have some metrics that are highly fluctuating. I have spike patterns at very low frequency, very high frequency. So you can set the scraping period fairly fast as well. And this is the main advantage. You basically are able to do whatever you want with your own Prometheus with just adding an extra parameter to it. I think that pretty much concludes the demo, as in this is all you need to actually do to get something up and running. And we're going to try to make things a lot easier with also Load Manager and the zones and tunnels. But eventually, all it comes down to is saying, I want a Prometheus instance, I want to call it demo, and I want to specify a bunch of parameters just to make it work, like an endpoint, and that's it. It should just be that simple. And we're going to continue to work to make this even simpler, because we know that this is a pain point. If you don't know what the load manager is, you don't want to care about alerting. So we want to mask that by default and only allow you to change it if you know what you're doing. But out of the box, it should be as simple as saying, in the end, this. I want to have a Prometheus instance, and I want it to be accessible here, and that's it. That's what we're aiming for, at least. And we're probably going to get that to that point fairly quickly. I hope you enjoyed the demo. I'm fairly impressed that it actually worked all the way through minus some quirks. If you have any questions, don't hesitate. Thanks.
Maybe we take a few minutes for questions if there are any still. I don't see anything new in the Q&A because I think you already discussed quite a lot.
Yeah.
Are there still people who want to ask questions? And then otherwise, let's give them a minute to respond. All right, I don't see anything new coming up. So I suggest we leave it at this. Thank you, Mickael, for your nice presentation and the demo. I thought it was really clear.
Thanks.
And thank you all for attending. I hope you can join us in the next session. We'll just post the new, the next sessions in this chat as well, so you have an idea of what's coming up. Basically, this is the end of the afternoon or of the morning program. We have the breakout session in the internationals room. You can check out the Hangouts chat room to find the link, or the website, of course. And we start back again at 3, and the first session at 3 o'clock is by, sorry, I'm doing this wrong, is by Eduardo da Silva, and I've posted the link in the chat. There's 2 more comments. I will also publish those. Oh, there's one more question I see from Remco. Yeah.
Would scraping DC target require a lot more config? Yes, in the sense that we have the DC service monitor currently, so you can use that. But it is quite unpractical currently. So we can make that work better in the future. If you want really to do metrics in data center to replace graphite, I'd suggest to currently wait for Prometheus and DC, because it will be a lot easier. So If you want to do this absolutely now, you can use this DC service monitor. It's in our docs, and follow this. If you prefer something that's more robust, I'd really advise to wait for Prometheus and Data Center. We're actively working on it, and it's going to come fairly soon, I hope. Is it advised to run your own Prometheus or just under really specific situations? So if you have other priorities than monitoring, for now, I'd say don't. Simply because, you know, it's nice that you can do so yourself, that you can have higher retention if you want to observe stuff a long run, if you want to have something with more detail than 30 seconds for every data point. But it's something extra you have to take into account. So if you were to start a new project, I'd say if you're feeling like pretty confident about your project in the first place, do so. In the long run, you will benefit from it. If you have no time, it's also fine for now to rely on the platform. We'll come up with a plan later on where things are going, what we advise to do in the first place. Are we able to configure the amount of samples using a query and accommodate for that by also scaling resource required to do so? Yes. So whenever you query something, you can define a hard limit in Prometheus on what's the maximum amount of samples you can use in a query. And on the platform, this is about 50 million samples, if I remember correctly. This is somewhere in the configuration flags. So you can set that up on Prometheus as well, on your own Prometheus as well. Here, it's the sample limit. And accommodating for scaling the resources required to do so. So if you deploy your own Prometheus, one of the things you can also do is say resources, and I want to have my limits for CPU being about 4 and memory being 4 GB or 5 GB. So you can easily change those numbers with an RTD2 run, and should be fairly easy. Say I now need 10 GB, well, I'll just upload the limits and run RTD2 again. We have to do this for our platform every now and then because the amount of stuff that's gathered and the amount of requests we get is fairly high and increases over time. How do resource limits work? Like how much metrics can you store by default? Out of the box, you should have enough to scrape a lot of stuff already. Prometheus is fairly efficient. Where you're going to have problem is if you ingest a lot of metrics at once on every scrape, then your memory usage is going to increase. CPU usage is fairly low. Like I said, we use 11 CPUs to scrape all of Pro and all of staging, and that's already like I said, like 3,000 pods. So that's a lot of HTTP calls. The main problem becomes when you start querying over, say, 3 months. What's going to happen is if you run out of memory, your pod is going to crash. So make sure to set your limits to something reasonable, and also requests to a certain decent level. Because if you don't do so, you won't have any memory reserved, and well, you won't get anything basically. So you can set a burst pretty high. Just be aware and monitor your Prometheus instances properly so that you know when you need more. What we're going to do likely is also provide dashboards showing you memory usage, disk usage, CPU usage, so you can easily set up those things and alerting based on that, so you can scale whenever needed. We can also think about later in the future adding automatically vertical pod scaling, as in increasing limits for you automatically. But this is a bit more complicated than just 2 minutes worth of effort. But eventually it's something we should look into, just so that you don't have to care about this either anymore. Within certain limits, of course. I think that's it. Thanks.